Hurricane Katrina's devastating power makes landfall on the Gulf Coast at wind speeds of 58 miles per hour and gusts reaching 90 miles per hour. The storm surge strikes Mobile Bay on the Alabama coast, causing severe damage. The World War II amphibious landing dock ship Shadwell and the former troop carrier State of Maine, berthed in a cove, are both swept from their moorings and dragged by the ferocious winds. Towards the end of World War II, in July of 1944, a Casa Grande-class dock landing ship known as ex-Shadwell or USS Shadwell was put into service. It measured 140 meters in length with a beam of 22 meters and a draft of 5 meters below the waterline. In the Pacific Theater, a Japanese torpedo attack damaged Shadwell. After the war in July 1947, Shadwell was taken out of service and placed in reserve as part of the Atlantic Reserve Fleet. In September 1950, Shadwell was recommissioned and saw service in the Atlantic Caribbean sector, which included several transatlantic voyages to the Mediterranean Sea before being decommissioned in 1971. In November 1988, Shadwell was moved to the Naval Research Laboratory's Fire Research Detachment on Little Sand Island, Mobile, Alabama. The US Navy used Shadwell as a test and evaluation platform for disaster management when developing fire models and other damage control technology. Essentially, Shadwell provided a realistic setting for scientists and researchers to test the effects of contemporary weapons. In particular, they looked for ways to suppress or counteract fire damage. Rather than having a military crew, Shadwell was maintained by civilians, an active duty officer, a lead petty officer, and 20 Navy Reserve sailors. The State of Maine, formerly the US Navy ship Upshur, is a Barrett-class transport ship measuring 163 meters long, 22 meters wide, and 8.3 meters deep. From 1952 until 1973, Upshur sailed in the Military Sea Transportation Service. In 1973, Upshur was renamed Training Vessel State of Maine and used by the Maine Maritime Academy as a merchant training ship. In 1995, Maine was transferred to the US Coast Guard's Fire and Safety Test Detachment in Mobile, Alabama, to serve as a testing ground for maritime firefighting technology. In the early hours of the 29th of August 2005, Hurricane Katrina wreaked havoc along the Gulf Coast, devastating 152 miles of coastline from New Orleans to Mobile. Hurricane-force winds and a storm surge 3.7 meters high flooded coastal cities, even reaching towns miles inland. Little Sand Island is an artificial island created from dredging spoils east of Mobile's main harbor canal. The Naval Research Laboratory Fire Test Vessel Shadwell and US Coast Guard Fire Test Vessel State of Maine use Little Sand Island as a mooring station. The anchors and moorings of the two vessels were uprooted and moved by the rushing water and hurricane-force winds. Shadwell moved 91 meters north, where it came to rest on the cove's northern beach. Twisted portside by the raging winds, Maine collided with Shadwell after traveling 18 meters north and 137 meters west. Its portside boarding ladder was crushed in the collision with Shadwell, and a porthole was ruptured. Maine settled on a sandbar at the entrance to the cove. Shadwell is beached on Little Sand Island with a severe list. In order to continue research operations, it needs to be righted and remoored. On the 7th of September, the Naval Research Laboratory requests assistance from the Naval Sea Systems Command to help return Shadwell to its normal mooring position. The Coast Guard Research and Development Center requests the Navy's assistance in repositioning the Fire Test Vessel Maine to its designated mooring place. A crew is dispatched to assess the feasibility of a salvage operation. The Naval Sea Systems Command sees this as a training opportunity for their Supervisor of Salvage and Diving Unit, SUBSALV. A Navy salvage expert and marine architects from the salvage contractor Don John Marine arrive at Mobile Bay for an initial inspection. They evaluate Shadwell's structural integrity to decide if it can be refloated. Shadwell's hull hasn't been maintained since it was decommissioned in 1970, especially below the waterline. In fact, the vessel has never been dry docked, and they're worried that rust has damaged the steel hull. They advised the Navy that Shadwell needs a thorough ultrasonic hull survey to assess the integrity of the steel hull and identify failures in the welds. Specialists look at how the beach will interact with a ship being dragged over the sand. They discuss the possibility of dredging the beach and the area surrounding Shadwell. They also assess the test ship Maine, which is grounded but less severely than Shadwell. Because Maine was in service until 1995, its hull is in better condition than Shadwell's. They check if the vessel can be towed and evaluate the mooring slip to see if it needs to be dredged. The surveyors come to the conclusion that both ships can be moved using a combination of selective suction dredging to provide buoyancy and a tug to help pull the vessels free. On the 13th of September, rescue and salvage ship USS Grapple is conducting a post-hurricane depth survey of Mobile Bay. Grapple is redirected to Little Sand Island to do a depth survey and find out how much dredging is needed to refloat the ships. The Naval Research Laboratory requests funding from the Navy to salvage and move Shadwell back to its mooring. Shadwell is over 60 years old and the Navy wants it scrapped, so they reject the proposal. But the Naval Research Laboratory argues that they can keep the costs down as long as the Navy performs a large portion of the effort, and recovering the ship will cost a fraction of the cost of replacing it. Over the past 19 years, $70 million has been invested in the fire testing program. The Navy will only need to pay about $1.3 million to refloat it. They point out that Shadwell has been reconfigured to simulate the different types of ships that the Navy uses, including a model that replicates several levels of a submarine's design. In the end, the Navy agrees that recovering the ship makes more financial sense and grants their request. In the proposal, they include relocating the Coast Guard vessel Maine, which is blocking the channel and has to be moved first. On the 5th of November, the Navy's Supervisor of Salvage and Diving, SUPSALV, hires private contractors to do an in-depth hull survey using ultrasonic testing. The survey documents the corrosion of the hull below the waterline and reports that the shell plating has corroded by as much as 30% in certain areas. Below the third deck, the longitudinals or stiffeners that run the length of the vessel to support heavy loads are seriously deteriorated and no longer structurally sound. There's a 5.8% decrease in the hull's resistance to bending. The welds are corroded, and there are obvious cracks in the corners where metal plates meet. Shadwell's hull is in bad condition and could collapse if a large force is applied, like pulling it along the beach to refloat it. Following the hull survey, SUPSALV enters the values from Shadwell and Maine's surveys into POSSE, the Program for Ship Salvage Engineering, a computer salvage modeling application. The Navy do love their acronyms. This modeling tool simulates the forces between the beach and the ship's hull and works out the stresses on the hull. The tool allows for hull corrosion and decreased structural support to be added into the analysis and tells them how much force they can use to pull the ship before it collapses. The investigation of Maine doesn't indicate any significant concerns regarding the strength of the hull. For Shadwell, they simply can't pull too hard. But the computation also shows that a shore-anchored hydraulic puller called the beach gear and the tug's pulling power together aren't capable of pulling the weight of the ship over the beach. On the one hand, they can't pull too hard or the ship will collapse, and on the other, they need to pull harder than their equipment will allow. If they can't pull it to the water, they need to bring water to the ship. SUPSALV, the Navy's salvage and diving unit, draws up a salvage plan to dredge a channel to the ship. SUPSALV assembles a team with the Navy's salvage contractor Don John Marine to act as the salvage master. SUPSALV's emergency ship salvage material contractor, ESSM, and the Navy's mobile diving and salvage unit, MDSU. I told you they love acronyms. The project team will also include the US Coast Guard Fire and Safety Test Detachment of Mobile. They'll provide a base to stage equipment and personnel, landing craft to transport equipment, a personnel boat for the diving and salvage unit, and they'll organize permits for dredging. The project will be financed by the Naval Research Laboratory. On the 1st of March 2006, over 6 months after Hurricane Katrina, the salvage operation gets underway with the construction of a berm on Little Sand Island. A berm is an embankment which will serve as a barrier to protect the dredge spoils from flowing back into the channel they're dredging. The salvage team works out how much dredging is needed for the project based on Grapple's depth survey. They need to remove almost 55,000 cubic meters of sediment. Don John Marine hires a local maritime construction company to build a berm large enough to hold back the dredgings. The berm will allow the dredge slurry to settle and seawater to flow out a spillway. Since Little Sand Island was constructed from dredging spoils, the US Coast Guard Fire and Safety Test Detachment easily secures a dredging permit. The maritime construction company supplies all the heavy machinery and labor to build the berm, and the Coast Guard supplies the transport vessels to and from the island. They use a 22-meter landing craft with a front landing gate for the machinery, a 10-meter workboat for lighter equipment, and 2 7-meter boats with capacity to transport 10 people at a time. The island's ground material is used to build the berm wall 3.3 meters high and 3 meters wide to allow construction equipment to drive along the wall. The berm wall is completed on the 30th of March, and the area can take over 300,000 cubic meters of dredgings. On the 1st of April 2006, the Navy Diving and Salvage Unit set up a station at Little Sand Island. The divers scout the area to get an idea of the size of the job while they wait for the dredger, salvage gear, and other equipment to arrive. Shadwell is marooned on the beach, its starboard side in the sea, its port side over dry sand, and its bow firmly pinned. Maine is grounded close by, off to starboard, aft of Shadwell in shallow water. The divers look for anything that'll get in the way of the dredging operation, and they check the hull of both vessels. They begin tidying and removing obstructions from the area surrounding the vessels. Shadwell's mooring line is unsafe, stretched beyond its limits. Because it's under such a large amount of tension, it's not safe to release the line by hand, so they set up a small explosive charge to cut the line. They remove a massive heavy tree that's blocking Shadwell's path. They clear out several ladders, walkways, and a portion of the shed that houses the shore power cable connected to Shadwell. There used to be a third ship moored on the south side of the cove. They search for its cement pilings and take note of their location so they can remove them later with a crane or explosives. Once the obstacles on land have been removed, the divers enter the brackish, silt-heavy water surrounding the ships to remove obstacles from the sea floor. Water visibility is 0, so they're forced to clear the shallow sections on their hands and knees, feeling their way around. They move cautiously. In the spring and summer months, Little Sand Island is home to some alligators, and some debris in the water make a large enough hiding place. It's only now that the divers realize the scale of the task at hand. Shadwell is harder ground, so the salvage team need to open a canal on its port side to make it float. On the 7th of April, excavators and bulldozers start removing the dry sand earth on the port side of Shadwell's hull. 3 days later, a large hydraulic dredger arrives on site. Since Maine has to be moved first, the dredger begins work on Maine's permanent berth at the same location it was originally moored before Hurricane Katrina struck. Shadwell and Maine need 2 deep water slips and a mound between the slips to keep them apart. The salvage team use a cutting suction hydraulic dredger, which is widely used to deepen sea channels. It has a cutter head at the suction inlet, which helps to loosen the earth and direct it to the suction mouth. The dredger sucks debris up a 38-centimeter pipe, then pumps it to the island's freshly built berm for disposal, operating around the clock in shifts. Metallic debris like wire rope, pilings, and old mooring chains frequently clogs the dredger, forcing the operators to stop and replace damaged parts or send divers to clear the cutter head. The divers set up the Emergency Ship Salvage Material, or ESSM, beach gear, which will help the tug pull Maine loose. While Maine's permanent berth is being constructed, the salvage team carefully planned Shadwell's extraction. On the 10th of April, flood alarms are installed in Shadwell, and 2 days later, a laser measuring system is set up to track changes in the hull at several locations. By the 21st of April, the salvage team has completed the shore-based excavation on the port side of Shadwell. They move the heavy machinery to the cove's southernmost point to dig Shadwell's new permanent berth. Sand is removed from the shallows on the southwest side of the cove by the excavator. Then a bulldozer is used to push and grade the excavated sand, creating a dune that will protect Shadwell from southerly winds. On the 26th of April, the salvage team bring in a second, smaller hydraulic dredger to speed up their work on Shadwell's new berth. The first dredger alternates between dredging the permanent mooring area for the two vessels and dredging the stern section of Maine to refloat the vessel. The plan for Maine is to dredge the stern to make it easier to pull, but not to the point that it floats entirely. Once the ground force is less than the pulling force of the beach gear and the tug in combination, then Maine will be pulled free of the bar and repositioned at its new mooring. Because the cove's bottom has large concentrations of clayish mud, the clay deposits don't break up easily with the cut ahead, causing delays to the dredging. Shadwell needs to be handled carefully. The salvage team uses a suction dredger without a cutting mechanism. Instead, a salvage diver uses a water jet to blow out the muck and debris underneath Shadwell's hull with a hose starting from amidship, and the spoils are pumped to the island's spoil basin behind the berm. To guarantee that every inch of space in the berm is used efficiently, dredge spoils are pumped to the middle of the berm where they're distributed evenly by bulldozers. On the 10th of May, after a month of dredging, Maine's ground force resistance is reduced to 150 tons, and the salvage team are eager to pull the vessel off the sand. Using 45 tons of pulling force from the beach gear, the salvage team attempts to pull Maine at the starboard bow. But after several tries, there's no movement. A strong southerly wind is blowing into Mobile Bay, raising the water level above the typical high tide. The salvage team uses two tugs to pull the stern of Maine to starboard at the peak of high tide, but there's no movement. They try again using the beach gear and the two tugs, but there's still no movement, so they continue dredging and set up a second leg of beach gear. On the 14th of May, after another 24 hours of dredging, the salvage team manages to dig a 9-meter deep trench along the length of the hull of both the port and starboard sides. The next day, the material supporting the hull gives way, and Maine floats free, allowing the salvage team to simply tow and maneuver Maine back to its original permanent berth. A temporary mooring is set up using the ship's port and starboard bow anchors set on the shore and one stern mooring leg. With Maine floating free and repositioned, both dredgers concentrate their effort on Shadwell, alternating between the vessel and the site of the permanent mooring. Between digging and dredging on the shore side, the team creates enough space for the large dredger to work on both sides of the hull. On the 12th of June 2006, after continuous dredging with both dredgers for almost a month, Shadwell's starboard list improves from 11 degrees to 6 degrees. Dredging continues while the salvage divers clear obstacles from the path. On the 16th of June, Shadwell shifts, moving from 6 degrees to starboard to half a degree to port, near enough level. The salvage team are encouraged by the development, so they try to push it free using the utility tug that provides daily support, but it doesn't budge. The large dredger continues to remove the clay soil from the starboard side of Shadwell, but it breaks down and takes 2 days to repair. After the repairs, the dredger continues to operate on the starboard side. The ship is resting on a ledge that runs the full length of the hull, which the salvage team expects will collapse once the dredger removes enough material. They're aiming for a period of exceptionally high tides, with the peak between the 24th and 27th of June. At 10:45 on the 26th of June, the base supporting the hull collapses, and Shadwell is released from the mud that's been holding it in place, floating with the rising tide. It's pulled out of the cove by local tugs, which turn it 180 degrees in the shipping channel, then maneuver it into its freshly dredged berth at the south end of the cove, south of Maine on Little Sand Island. Over the course of 2.5 months, the team successfully refloated Shadwell and Maine, returning the vessels to their permanent moorings. Naval Research Laboratory initially paid the entire cost of the operation, and billed the Coast Guard for their share to simplify the accounting process. The salvage operation cost came to $3,144,689.31 in total, of which roughly 2/3 was allocated to Shadwell and 1/3 to Maine. In October 2016, a decade after being recovered, Shadwell was retired from the Naval Research Laboratory. In February of 2017, Subsalv took responsibility for the removal and disposal of Shadwell. A survey found that the vessel's structure was severely deteriorated and that 60% of its length was stranded. If the ship was pulled free, it would likely tear apart. So Subsalv scrapped Shadwell in place and removed it from Little Sand Island piece by piece over 228 days. To watch more salvage videos, click the link on screen now.